Hi, good day. I'm Dr. Chen Chen. Thanks for watching. In my previous video, I discussed about the precast production facilities like ICPH and ICP. In this presentation, I will talk about production software. Different core software systems serve different roles in manufacturing plants. Though these software systems can be used separately, it is recommended to have them work together. This slide shows the ISA 95 pyramid. The framework provides guidance for how the shop floor should view the ERP, the MES, and the SCADA. ERP, MES, and SCADA run on different time horizons. ERP, short for Enterprise Resource Planning, controls enterprise-wide administrative and business processes. MES, short for Manufacturing Execution System, is closely related to the production line to continuously optimize production and record production process information and technical parameters. ERPs for manufacturing act as a top layer to handle orders and inventory, while an MES focuses on real-time operations on the floor. With an MES ERP integration, the MES system helps in sending data to the ERP system. SCADA, short for Supervisory Control and Data Acquisition, is an automated remote monitoring and control system. We move towards digitalization. More integration is necessary. The goal of integration is to improve the manufacturing business process. An integrated set of business applications allows design, engineering, planning, procurement, and manufacturing execution to use the same data structures to represent the product's real-world data. PLM, short for Product Lifecycle Management, is a software solution that manages all the information and processes across globalized supply chains at every step of a product or service lifecycle. A bill of materials is essentially a blueprint for manufacturing a product. It encompasses the materials, components, and steps required to create the item. There are different structures of BOM. For example, the EBOM is a type of BOM that defines the product as designed. The MBOM defines the parts that are needed to manufacture a product. BOM should be the connection point for traceability during core integration between PLM, MES, and ERP. ERP systems are the brains for smart factories. The history of ERP dates back to the 1960s and 1970s, when companies started using mainframe computers to automate certain business processes, primarily inventory management. At that time, the focus was on MRP systems, which aimed to optimize the production process by calculating the most effective way to allocate resources, minimize inventory levels, and prevent shortages or surpluses. With the advent of personal computers and client-server architectures in the 1980s, MRP evolved into MRP2 to allow for more customization and scalability options. Then, in the 1990s, a more advanced and extended version of MRP and MRP2 came, This was termed ERP. ERP brought other business functions like accounting, sales, engineering, and HR to serve as a single source of accurate data for all employees. In the 2000s, ERP was able to integrate with a number of different software, including front office applications like CRM, BPM, SRM, etc. And in today's time, the ERP system has evolved even more. The solutions of ERP now have gone mostly cloud-based. Compared to traditional on-premises ERP systems, cloud-based solutions offered greater accessibility and better support for remote work, as they could be accessed from anywhere, anytime, and on any devices with internet connectivity. As a result, businesses could streamline their processes and gain better visibility into their operations by integrating data from multiple sources in real time. This slide displays common ERP solutions used in precast plants. ERP Betsy is a specialized system for precast concrete manufacturers, while others are for general purposes. Among them, Adaptive is a tech firm in Singapore founded in 2013. This slide takes one typical ERP solution as an example to illustrate its functionalities. It has modules for human resource, risk management, procurement, ERP analytics, and supply chain management. Because planning and scheduling functionality is not the main focus of ERP systems, ERP systems often lack the ability to create accurate production schedules. As a result, some manufacturers with ERP systems still rely on spreadsheets for their production scheduling. An APS tool is designed to support complex planning processes and integrate the results efficiently into ERP. While ERP focuses on managing resources, APS focuses on managing constraints. Though the APS software sits independently of the ERP, the two work best when paired together. The traditional production planning and scheduling system used in MRP2 has a hierarchical structure as this slide shows. The longer the planning horizon is, the higher the uncertainty will be. Strategic planning is clearly of long-range scope and is a responsibility of senior management. Tactical planning is a medium-range activity involving middle and top management, concerned with the effective use of existing resources within a given market situation. Finally, operational control involves short-range actions typically executed by lower levels of management and non-management personnel to efficiently carry out the day-to-day activities of the organization. The central component of the whole framework is a master production planning. It serves as the primary interface between marketing and production, and essentially drives all of the shorter-run operations. In essence, the master production planning takes the aggregate production plan and disaggregates it into a production schedule of specific products to be produced in particular time periods at each manufacturing facility. The APS software has the potential to replace some or all of the traditional production planning, scheduling, and capacity planning of MRP2. The MRP2 model suggests using different approaches for planning and scheduling over various time horizons. However, each approach has its own version of capacity planning, which assumes infinite capacity and static lead times and hence doesn't work efficiently. In contrast, APS can explode BOM and consider capacity explicitly, making it possible to replace the entire MRP2 planning and scheduling paradigm with a highly effective APS module. As customers' preferences for highly customized products continue to grow, the pressure on the production planning and scheduling process increases, making it more complex than ever before. In an APS system, it is essential to represent the restrictions accurately, which is a common occurrence in real-life production environments. For example, machines and personnel cannot work an infinite number of hours. Not all machines and personnel can handle all work processes. Storage and delivery capacities are scarce, and the quantity throughput in production is limited. Unfortunately, developing an APS faces four serious limitations. They are limitations in computing power, inability to fully model the production environment, optimization deficiency, and slow planning and scheduling. These challenges seem so difficult to overcome that a complete solution was never attempted. Over the past 2 decades, researchers and engineers have spent a lot of efforts to tackle them. Each solution was a significant breakthrough. They are still working hard. The APS kernel comprises various methods such as linear programming, constraint-based programming, heuristics, and algorithms. However, each of these methods has its own set of limitations. For example, linear programming fails to handle uncertainty, and there are restrictions to linear objective functions. Nonlinear programming can be very difficult, and a fractional solution may have no meaning. Additionally, it is extremely challenging to reduce the world into a set of linear equations. Constraint-based programming can be too restrictive, leading to suboptimal solutions. The search space can be too large, making the problem intractable, or the constraints can be too weak, resulting in an infinite search space. Heuristics offer inherent flexibility, but their solutions cannot always guarantee the best results. Quick decisions without all the information can lead to errors in judgment, and miscalculations can cause mistakes. The flexibility can also lead to misleading or fraudulent manipulations and solutions. Lastly, algorithms can be time-consuming, and big tasks can be difficult. It can be challenging to show branching and looping, which can further complicate the process. There are numerous off-the-shelf APS software solutions available in the market. However, for solving specific planning problems, tailor-made algorithms are necessary, which means bespoke software may be required. Off-the-shelf APS software systems have certain limitations, as illustrated on this slide. Their mathematical models rely on simple assumptions and can only be effective in certain situations. The production system's capacity is predicted based on cycle time using low-fidelity simulations, which provides a rough estimate and cannot prioritize tasks. Additionally, the high-fidelity simulation used to compare different strategies requires long computation times and involves rule-based decision-making. Before ending today's presentation, let's watch a video about APS.
We're here at IMTS, the largest manufacturing technology show in North America. Behind me, we have the digital to real demonstration for a light-weighted EV component displayed here at our booth. As we transition from the design stage, we are now at the advanced planning and scheduling station with Blake. Here we're going to learn how we can see manufacturing process planning happen in real time on the shop floor for items such as inventories and orders.
What we've seen now is Benmar on the technical side from process planning, and now it's time to look at the execution side of things and the business side that we see on the right side here. Siemens Portfolio Ops Center covers that side with multiple products such as manufacturing execution, enterprise manufacturing intelligence, advanced planning and scheduling, research, laboratory and design, and quality manufacturing. This all falls on the Ops Center portfolio. Today we're looking at advanced planning and scheduling, which consists of two parts: the advanced planning, which is your long-term, putting things into monthly buckets, looking out over a horizon of a year, 2 years, multiple years down the line. And then we also have scheduling, which is your short-term, down to your days, hours, minutes, sequencing orders against the plan that you created. So I want to take a quick look at the video here. Here we see our customer orders, the knuckle that we're producing here today. We can see those different orders. And when we flip over to the Gantt chart here, we'll see a snapshot of our entire manufacturing facility with all of our resources. On the left-hand side, you can see the diamond on the top, which points out your supply, and the diamond on the bottom, which is your finished goods going out the door. And here we can see a routing throughout the entire process, where we start on the laser tech, down to the monoblock, and then the spindle that's being done on the Sinumarks, and that comes together in assembly. It synchronizes up so that everything comes together in assembly at the same time. And then what we can also see here is if there's any problems in the manufacturing process, so whether that's labor, whether that's a machine breakdown, and we're going to show that example here soon, where we'll see a red fence block off the laser tech here and push those operations out. And what this tool is helping us do is rescheduling those operations so we can figure out what the path forward is, knowing that we've had this breakdown. And then, so you can see that here posted up. And as we reschedule, it pushes those operations out and allows us to know what our path forward is from there. So when we talk about it, the scheduling side is more of a plan going into it. And what we want to do is get that feedback from the shop floor, and that's where we look at the execution side of things in our manufacturing execution system so that we can get the real-time data from the shop floor and update that against our schedule and replan from there. When we look at a future digital state of a manufacturing company, we can see this is how we typically architect things, with data coming from your ERP into the MES and scheduling happening from there.